Fine-tuning with MLX. I know. I did that video last week, and all of you Windows and Linux users are going to be upset at me because I said I was going to do something on unsloth, but here I am doing something about a Mac-only solution. Actually, that's not true. The same Mac-only solution. Again. But wait, it's okay. You will benefit from this. You see, last week I did a video, and it was pretty well received. It got more views more quickly than anything I've done before. But some of the comments on the video pointed out issues that appeared in the video. First, some folks were upset that I didn't include the code for creating the dataset. Additionally, I didn't provide any examples of what the dataset actually looks like. And I kind of got the format wrong. Well, not quite wrong, but it was suggested that there was an easier way to do it. And then I talked briefly about the fact that I was creating train.jsonl, test.jsonl, and valid.jsonl. However, I didn't really explain why I need those files and what they are, so I'll discuss that a little bit more as well. And then I talked about JSONL in a way that was, kind of negative. I didn't really understand the benefits of JSONL and how it relates to JSON. And then comments came in about JSONL, and I still kind of dismissed them because I thought it pointed out a problem that Python was trying to get around. However, now I understand why folks think that JSONL is interesting, and so I'll talk about that. And finally, I got something wrong with how I created the model in Ollama. I assumed I needed to use one model, but it turns out I needed to use a different model. It's a somewhat minor change with a pretty big impact. We'll talk about that here as well. Getting all these things sorted out will ensure that the unsloth video is even better when I do that. All right, let's get into this. In the last video, I demonstrated how to create a dataset. It wasn't a great dataset, but the first thing I did was look at the format on Ollama.com for that particular model, Mistral. Then I incorporated that format, including all the special tokens, into the text prompt. It was suggested that I don't need to do that step and can instead use objects with prompt and completion. So I updated my code to format the dataset with a series of objects that look like this. But it didn't work. It seems that the docs for MLX suggest that this format is possible, but in order to use it, you need to install another module and add a config file, and that config file must reference a dataset up on Hugging Face. It doesn't seem to work with datasets that are local. I would love to know if there are any other ways to do this, but for now it seems that we just have to use the objects with a text key only. Now this time around, I have the code for the project in the repo. You can find it at github.com/technoevangelist/video projects, and then look for 2024-09-06 fine-tuning because I'm posting this video on September 6th. It's written in TypeScript using Bun. I bounce around between Bun and Dino, and I'll probably be doing more with Dino again in the future. Turns out most of the Bun benchmarks were kind of bogus. Yeah, benchmarks suck in other tech areas, not just with AI models. The code I wrote for this isn't code I'm proud of, just something to get the job done. Now, it outputs 3 files, each with a JSONL extension. First there's train, then valid, then test. So the question came up of, what are these for? Well, train.jsonl is the main training data. This is what the fine-tune uses to actually do the fine-tuning. Valid is validation data. It helps evaluate the performance of the model on data it hasn't seen before. And test is for testing after the training is done. It looks like the test data isn't actually used by the training step. Later, when I show the MLX command, it uses the train flag. If you change that to a test flag, then it will use the test data. But creating this was automatic, so creating test was 0 extra effort, and it may come in handy later. I don't know. Okay, now how about JSONL versus JSON? The suggestion was that this made it easier to work with larger files. First, I thought this was because Python couldn't work with larger JSON files without it all being loaded into memory. Turns out there are libraries for doing that in Python, as well as TypeScript and lots of other languages. But sometimes it's useful to manipulate the files from the command prompt. Bit of a weak argument, but it's the format we're stuck with, so not worth fighting over. It's like Python versus, anything else. It's a language folks seem to think they're stuck with, even though there's so many reasons to go with anything else. So now we have our JSONL files and we're ready to fine tune. There's nothing different about this step versus what we did in the previous video, apart from it being better to download the model first and then running the MLX command. I like to use Hugging Face Downloader, which you can find at this repo. Then you can download the Mistral model with this command. Mistral requires you to be logged in to download the model, so be sure to get a token and include it on the command line. The one on the screen isn't real. So now you can run the MLX command. Here's what I used. Notice that the model is now pointing to the local copy rather than the Hugging Face repo. When that's done, we can create the model file. There are two differences here this time. Instead of saying from Mistral, instead we're saying from and then the path to the downloaded Hugging Face model. And then since we don't have the template set, run Ollama Mistral -- model file, and that'll show us the model file for Mistral, assuming we have Mistral downloaded. Copy the data for the template and the parameters and paste that into our new model file. And be sure to include the adapter line that we used last time. Now, run the Ollama create command. This is also going to be a little bit different if we want a Q4 model. So Ollama create Mistral -f model file, and then add -q q4_0. So this is going to create the Mistral model and then quantize it all in one step. Well, that's pretty cool. It doesn't take very long to run, and the results seem to be a bit better for me. Still not great, but that's because my dataset isn't all that great. Again, creating a great dataset is the part that's going to take the most time. But now you should have everything you need to turn that into something really useful for your needs. What do you think? Have you attempted any fine tunes yourself just yet? I would love to know what you're up to, so share it in the comments below. And be sure to subscribe to the channel to find out when the next video comes out. I love making these videos, and hopefully you love watching them. So thanks so much for being here, and goodbye.